Alright, last part of the exam, we're on to Turing machines. I'd leave this to the end. Turing machines are usually pretty laborious. Okay, the following diagram shows a Turing machine whose purpose is either to accept or reject the input string, blah blah blah. Okay, initially the head is somewhere over the input string. For each of the strings, blah blah and blah, determine the content of the tape after the machine is terminated with the given string as an input. Unfortunately, there really is no fast way to do this. There's no clever way to do this problem because we know in general, by Rice's theorem, there's no way to analyze the behavior of a Turing machine that isn't just run the damn machine. So, I mean, you really just kind of have to crank it out for this one, unfortunately. So I'll crank out the first one, and then I'll just give you the other two answers for free because I'm a bit lazy. So let's consider if we had 0, 1, 0, 1, 0, 1 on the tape. We have blanks everywhere else. And the tape head starts, I don't know, maybe here. So what am I doing? If I see 0, write 0, move right. If I see 1, write 1, move right. So I go step, 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 step. See a blank, write a blank, move left. Go to state S1. See a 1, blank it out. Move left. So I replace this with a blank, and then I move left. CA0, blank it out, move left again, and then go back to S0. Okay, this is going to do the same thing. Blank, 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 and then I'm in S0 and I see a blank. See a blank, write a blank, move left. See a blank, write a blank, stop. And then go to the halting state. Okay, cool. So it looks like, I better write this out formally. So let M be this Turing machine, then M fed this string is going to output the empty string. It happens to be the case if you run the other two cases, which I leave to you as an exercise. You crank it out. This one gives you 0, and the other string gives you 1. Okay, just crank it out, and that's what you happen to get. So, whoops, did we skip a question? Yes, we did. Given an input string S, describe the output after the machine is terminated on an input string S. So how does this machine work? I mean, you'll sort of find out by running these two cases. Essentially what it does is it deletes a 0 and then deletes the next corresponding 1, either by blanking it out or overriding it with a 0. And if it sees a 1, then it destroys a 0 as well. So basically it destroys the bits in pairs. It sees a 0, destroys it, and a 1. It sees a 1, it destroys it, and a 0. And it'll keep doing that until either there's nothing left, or there's only 0s left, or there's only 1s left, in which case it will just return however many unpaired 0s there are, or however many unpaired 1s there are. So what's a nice formal description of that? Maybe I could say, let n0 be the number of 0s in the string S, and let n1 be the number of 1s in the string S. Then M of S does the following action. It returns the empty string if they're the same number of 0s as 1s. It returns all the unpaired 0s, so however many 0s are left over. So I guess that's going to be the number of 0s, take the number of 1s, if there are more 0s than 1s. Otherwise, it returns the number of 1s minus the number of 0s, that many 1s, if there are more 1s than 0s. There you go, there's a nice formal definition of what it does. Explain, no formal proof required, why the machine will always terminate regardless of the given input string. Okay, so how this machine works is it basically destroys a 0 and then overwrites a 1 or just deletes the 1, or it deletes a 1 and either destroys or overwrites a 0. So basically this machine executes a loop. So the machine does a loop, and at every stage in the loop it destroys at least one bit. And at each loop at least one bit is deleted from the input string. Is deleted from the input string. Okay, well, since the input can't be infinitely large, that is, the input string must be finite. So since cannot have infinite inputs, infinitely long input, that means eventually all the bits in the input are the same, or we run out of bits. So eventually run out of either zeros or ones, or both, if they were the same number. So that means this process can't run forever, so hence it must terminate. Must halt. There we go. That's probably a sufficient description. I mean, maybe we should like to write a little bit more about what the machine actually does. So maybe the machine does a loop where at each stage it deletes a 0 and then deletes or overwrites a 1, or deletes a 1 and then deletes or overwrites a 0. So that means at least one bit is deleted after each loop, and the string can't be infinitely long, so eventually we've got to run out and this process must terminate.